Hello everyone and welcome to this video. Okay, let us start our discussion. Today we want to talk about determinant, like if a matrix is given to us, how we can find the determinant of this matrix. Okay, let's start with 2 by 2. 2 by 2 means a square matrix of order 2. Let's say we have a matrix A, which is A, B, C and D, and we want to find the determinant of this matrix. The notation used for determinant is like A and two vertical bars. Okay, this is the notation of determinant. It's also called mod, like A mod, A determinant. How to find it? For a 2 cross 2 matrix, first replace these square brackets with vertical bars. This is the determinant. Okay, this is the determinant. Now how to solve this one? You have to multiply the elements of the diagonal. Like first multiply A with D, so it will be AD, then a minus, and then the second diagonal, which is BC, so BC. So what's the answer? AD minus BC. This is how we find a determinant of a matrix of order 2. Let us solve examples. Let's say we have a matrix A, which is 2, -1, 4 and 3. We want to find the mod of A or determinant of A. So first replace the brackets with vertical bars. 2, -1, 4, 3. Now how to solve it? Multiply the elements of the diagonal. So 2 3s are 6, minus this one, -1 into 4 is -4. So minus minus becomes plus, 6 plus 4 is 10. So mod of A is what? 10 here. Another example is matrix B, and it is 1, 4, 2, 8. We want to find mod of B, the determinant of B. Replace the square brackets with vertical bars. 1, 4, 2, 8. Now let's multiply the diagonals. 1 8s are 8, minus 2 4s are 8. So 8 minus 8 is 0. In this case the determinant is 0. So we solved two examples. In one example the determinant was 10, and the second example determinant is 0. When the determinant of a matrix is not equal to 0, it can be positive number, it can be any number, but not 0, we say that this matrix is non-singular matrix. This matrix is non-singular matrix. And if the matrix determinant is 0, we say it is a singular matrix. This is a very important concept because later on when we will talk about inverse, like how to calculate matrix inverse, A inverse, if it's a singular matrix, if A is a singular matrix, let's suppose, then the inverse does not exist. We will say no solution. So inverse only exists for a matrix which is non-singular, because what's the formula? In the formula it is like adjoint of A over A mod, determinant of A. If this determinant is 0, then inverse does not exist. So when we will define inverse, we will say it's a non-singular matrix A. Okay, this is the method for finding inverse of 2 cross 2 matrix. Let's say we have order more than 2. Let's say we have 3 or more than 3. Let's start with 3. Let's take a journal matrix. We want to solve this one. Like we have A11, A12, A13, A21, A22, A23, A31, A32 and A33. We want to solve this one. How to solve it? To solve it, first we need to understand two minor concepts. One is called minor element. Minor of an element or minor. It is written as Mij. The notation or the general format is Mij, where I is the row and J is the column. I represents row and J represents column. What we have to do, simple, that we take a row and we take a column and we delete it, we remove it. The the remaining one is known as the minor. We call it word minor. Let's suppose, for example, we want to find minor M12 for this matrix. It means first row, second column. It means what? First row and second column. So we take out the first row and we take out the second column. What's left with us? We are left with A21, A23, A31 and A33. This is what? This is minor M12. Okay, so you M12 means first row and second column, remove it, the remaining one will be your minor. Okay, now another thing is called cofactor. Cofactor. What is cofactor? Again, it's Aij, the general format. I represents the row, J represents the column. My spelling must be wrong. Now here the formula is -1 I plus j into mi. Like for example, you want to calculate the cofactor A12, like A12 now. How to calculate it? Just replace I with 1, j with 2. So you will have -1 1 plus 2 into M12. -1 power 3 is negative, so -1 into M12. This is cofactor. This is called cofactor. Like if you want to find A22, it will be -1 2 plus 2 into M22. So -1 power 4 M22. Negative power is always positive. It's even, like 4, it will be positive. Whenever you want to check it, if you want to check it, don't write on calculator like -1 power 4. In this case, it will only take 4 times 1, not minus. So it should always be -1 raised to power 4. So you will get M22. This is the cofactor of A22. When you want to find determinants of order 3 or more than 3, it is simply this statement. You can use this statement. It is what? Sum of products of elements, either a row or column, with its cofactor. With its cofactor. This is the statement. If you know this, you can solve determinant of any order, 3, 4, 5. We can solve. Let me explain it. For example, we have a matrix A, or we want to find determinant of A, which is A11, A12, A13, A21, A22, A23, A31, A32 and A33. We want to find the determinant, so it is what? It is a sum of products of elements, row or column, with its cofactor. Take any row or any column from here. Take any row and any column. Let's suppose you take this row, A11, A12, A13, any row or any column, and multiply it with its cofactor. Like we have it, like A11 into A11, its cofactor, plus A12 into A12 plus A13 into A13. This will be the mod of A. Take any row. Like if you don't want this row, you can take the column also. Take this column, complete column, not partial. It will be what? In this case, you have mod of A12 into A12 plus A22 into A22 plus A32 into A32. Agree? Okay. Now you will also see in some books they can use, like they can convert this cofactor into minor also. Yes, this is convertible, and it's very easy in this case. Let's say here, this one, if I, instead of using cofactor if I want to use minor, like you will see in books also with minor. So this is a11. Now a11, if you solve here a11, it will be put minus 1 power 1 plus 1 into m11. So indeed minus 1 square, minus 1 square, so this will be positive again, because square of negative is positive, so you will get m11. So you have a11 m11. Now if you come here, this is a12, a12. So if you take minus 1, it will be minus 1, 1 plus 2, it will be minus 1 cube, so this will be negative. So it will be what? This will become minus a12 into m12, because this is how you solve the cofactor. Cofactor, so when you want to solve cofactor, it's how aij is minus 1 power 1 I plus j into mij. So you can replace the value of aij directly also. This one is 3 plus 1. This is 4. So it's even power, so it will be positive. So a13 into m13. See, some books will solve questions like this also, some will use directly this also. Whenever you have the number odd, like then you add the row and column number, it's odd, surely it will be with negative sign, because in cofactor it will become negative. Okay, let us try to implement this now on a question. Let's say we have a question. Let me take a question. Yeah, we have a matrix A, 1 minus 2 4, we have minus 2 3 and minus 3. Here we have 3 1 and 2. Yes, we have the correct question. We want to find first the cofactors. a12, we will find a22, and we will try to find also a32, and then we want to find the determinant. This is the question which has 4 parts. It says find first a12, cofactor a12, a22, a32, and then the mod of a. Let's start with a12. First write the general formula. aij is minus 1 I plus j into mij. We want to find a12 first, so let's go with a12. So minus 1 1 plus 2 into mij, so m12. We have minus 1 into m12. Now when we want to find m12, it means what? You delete the first row and the second column. So delete the first row. When we remove the first row and the second column, we are left with what? This is minus 2, 1, 4 and 2. Minus 1 into minus 2, 1, 4 and 2. So minus 1 into minus 2 into 2 is minus 4, and 4 into 1 is 4, minus from the formula minus 4. So when you solve, it becomes minus 8, which is equal to 8. This is minor, and we got the cofactor a12, which is 8. Right? Now let us go back to the question. Let me fix it. It's 1 minus 2 3 minus 3, and this one is 3 1 2. Now we'll find cofactor a22. a22 is going to be minus 1 power 2 plus 2 into, first let me write the equation, then we will solve it. It's always good to do the steps. m22, so it is minus 1 power 4 is positive, so m22, it's equal to m22. Now for m22 we have to do what? Remove the second row and second column, like this is the row and this is the column gone, so we are left with 1 3 4 and 2. We solve it. It's 1 2s are 2 minus 12, so it is minus 10. It is equal to 2 2, which is minus 10. Right, now let us find A32. We want to find A32 now. Minus 1, 3 plus 2 into M32. This is minus 1 into M32. When we want to find M32, it means we have to delete the third row and the second column. Third row and the second column. We have here minus 2 and we have here 1. So we remove this one, third row and second column, we are left with 1, 3, minus 2 and 1. Right? This is how we are doing so far. So have minus 1 into 1, 3, minus 2 and 1 that we got when we removed the third row and the second column. So minus 1 into 1 ones are 1 minus from the formula, and 2 threes are minus 6. So when we solve it, it becomes 7, because 1 plus 6, 7, then times by minus 1, it will be minus 7. The cofactor A32 is minus 7. Okay, let us rewrite the question and make it easy. We have to find now the determinant. We have 1, minus 2, 3, minus 2, 3, 1, 4, minus 3 and 2. We got the cofactor A12, which is 8. We got cofactor A22, which is minus 10, and A factor 32 is minus 7. Now we want to find the determinant. Determinant is actually we defined it in a way that it's the element multiplied with its cofactor. And which element? Any row or any column. So if you see, this one is A12, A22 and A32. This is A12, A22 and 32. Eventually this is the column. This is the complete column. We have the cofactors. We have the cofactors of this. We can directly multiply it with the element, add them, we get the determinant. What's the formula? We said formula was take any row or any column, and multiply with cofactors. We already calculated the cofactors. So instead of solving a question again, we can use the cofactors here. Like we have A12 into A12 plus A22 into A22 plus A32 into A32. This is the element multiplied with its cofactor. So we are using this because we already have cofactors. Like if you don't have the cofactors, then you can use minors also. We will solve this question with minors also after this, because we have it, so we can continue. It's A12 is minus 2 into A12, which is 8, plus A22 is 3 into minus 10, plus A32 is minus 7, sorry, minus 3, I mixed it. This is minus 3 into minus 7, minus 16, minus 30, plus 3 sevens are 21. And when we solve it, we get what? I think we get negative 25. Yes, we get negative 25. This is the mod of E. We got it through the cofactor part. Now we solve the same question. Let's try to use another row. Let's verify if it is correct. Like you multiply any row or column with its cofactor, it's the same thing. Let us try this one now. Instead of using, you can directly use the minor also if you have clear with the minus sign. Let's do with minor, like 1, minus 2, 3, minus 2, 3, 1, 4, minus 3 and 2. This is, we want to find the mod of this. So take any row or column and multiply with its cofactor. This was the concept of determinant, right? So we have here A mod let's take this row now. Let's take this row and multiply with its cofactor. So it's 1 into A11. A11 will be remove the first row and the first column. So we are left with 3, 1 minus 3, 2. 3, 1 minus 3 and 2. Then there will be a minus. Why minus? We can explain here. The mod is A mod A11 into A11 plus A12 into A12 plus A13 into A13. Now A11 into A11, if you convert this A11 into minor, it is what? Minus 1 power square into M11. So minus 1 square will make it positive, so it is A11 M11. A12, this is minus 1 power cube, so this one will be negative. We discussed it before. If it's when you add them, the position, if it is 1 plus 2 odd, it will always be negative, so it will be minus A12 into M12, right? This is 1 plus 3, this is positive again, so because it is even, so it will be positive, so A13 M13. So you can use this formula directly if you want to ignore the problem. In a 3 by 3 matrix, the middle one will be negative, like A12 in this case will be negative, so negative into negative 2. Now we want to find M12. M12 means first row, second column. Remove the first row, and second column. We are left with minus 2, 1, 4 and 2. First row means this row, and second column this one gone, so what's left? Minus 2, 1, 4 and 2, minus 2, 1, 4 and 2. Now third one is, this one will be positive, plus 3. A13 you want to find, to go on the first row and the third column, we remove it, it's minus 2, this is 3, this is 4 and this is minus 3. Now we will solve it. We will see, we will get the same determinant. This is 1, 3 2s are 6, minus 3 into 1 is minus 3, plus 2 into minus 2 into 2 is minus 4, 4 1s are 4, minus 4, plus 3, minus 2 into minus 3 is 6, minus from the formula 4 3s are 12. Okay, we just perform the diagonal multiplication and in between a minus sign. So we have here is 6 plus 3, it's 9, plus 2 into minus 8, and 6 minus 12 is minus 6, minus 6 into 3, minus 18. So 9 minus 16 minus 18, which is minus 25. So we proved it. See, we showed it. First we solved this question using this column because we calculated the cofactors. Now we use this row, we use this one, and we directly calculated the minus, and we implement the cofactor part here, because when we have the row and column addition odd, it will always be with negative. It will always be negative. Like if you want to take this row, then this one is A31, so this will be positive because 3 plus 1 is 4, it's positive. This is 3 2, 3 plus 2 is 5, so this will be negative. This is 3 3, 3 plus 3 is 6, so this one will be positive. This is how you can find the determinant. If it's a 4 by 4 matrix, same rule can be implemented. It has more techniques also to help. In the coming lectures we will discuss about it also. Okay guys, that is all for today. Thank you so much for your time. Thank you.